Hi everyone, it's Calculus by Christee, and in this video I'm going to go through a free response question that was on the AP Calculus exam in 2021. One of the best things you can do to prepare for the AP Calculus exam is to practice free response questions from past exams. In the description below, I've provided a link to College Board's website where you can find this question along with scoring guidelines and even sample responses. I will be bringing you free response practice until the AP exam, so make sure to subscribe to see those upcoming videos to help you prepare. And comment below about any questions you have, and check out the rest of my channel for videos on various calculus topics. Let's get started. Here is question number 3 from the AP Calculus exam, and put those calculators away because this one is a non-calculator question. All right, this problem reads, a company designs spinning toys using the family of functions y equals cx square root of 4 minus x squared, where c is a positive constant. The figure above shows the region in the first quadrant bounded by the x-axis and the graph of that same exact function for some c. Each spinning toy is in the shape of a solid generated when such a region is revolved about the x-axis. Both x and y are measured in inches, and because they give us that unit, we'll want to make sure to give our answers with units. Part A reads, find the area of the region in the first quadrant bounded by the x-axis, which is right here, and the graph of this curve when c equals 6. So we are looking for the region bounded between those two, which, you know what, is going to be this green region right here. We want to find the area of that region. Well, finding the area of that region involves taking an integral from this intersection point to this intersection point. So that's going to be my first part of this problem, is finding where these two functions intersect. So I know I want to find where the x-axis, which is a value of 0, intersects with my red curve, which was this y equals cx square root of 4x squared for a c value of 6. So that's going to be the function 6x times the square root of 4 minus x squared. And now I just need to solve this. So if 6x times the square root of 4 minus x squared equals 0, then either 6x is going to equal 0 or the square root of 4 minus x squared is going to be equal 0. Solving the first one, I get x equals 0. Solving the second one, let's see, I would square both sides, add over the x squared, take the square root, and I get plus or minus 2, but you can see here in this problem that I'm going to use the x value of 0 and the x value of 2 as my two intersection points. So now I can use that for my integral. So I'm finding the area from 0 to 2 of the region under the curve of 6x times the square root of 4 minus x squared, and that is all dx. And now I need to evaluate this integral, and once again, I cannot use my calculator, so I have to evaluate this integral by hand, and I'm going to use u substitution. So I'm going to make my u value be 4 minus x squared, or what is underneath the radical. That's going to be a common place to find your u. And so my du is going to be negative 2x dx. From here, I know there's a bunch of different ways that people do u substitution. What I try to do is I try to form what's left over, like what's outside of the radical u. So I try to form 6x dx over here. And again, I know there are so many different ways that people go about it, but what I do is to form 6x dx, I know I need to multiply both sides by negative 3. And so then I would have negative 3 du equals, there's my 6x dx, so I'm going to replace this 6x dx with negative 3 du. So as I find the area here, remember I do need to change my bounds. So right now my bounds 0 to 2 are in terms of x. I want to change my bounds to be in terms of u. So if I started with a bound of x equals 0, I know that is going to change to a u bound of 4 minus 0 squared, which is 4. And then if I had a bound of 2, that's going to change to 4 minus 2 squared, which is 4 minus 4, or a u value of 0. So I'm going to go from a u value of 4 to 0, which, by the way, I will change in just a minute to make them switch. And let's see, the 6x dx I'm replacing with negative 3 du. So I'm actually going to bring that constant of negative 3 out in front. There's my du, and the square root of 4 minus x squared would be the square root of u, which is the same thing as u to the 1/2. So I actually like my bounds to go from the least value to the greatest value. So I'm going to switch this around to go from 0 to 4. And when I do that, I need to change the sign. So right now it was a negative 3. So that'll be nice. That'll change it to a positive 3 of u to the 1/2 du. Okay, now I'm ready to integrate. So I'm going to have 3 times, and then I would have u to the 3/2. I'm going to add 1 to the exponent and divide. And then I'm going to evaluate this from 0 to 4. And there's some little simplifying we can do here. So if I multiply 3 times 2/3, I would just have 2. And then u to the 3/2 from 0 to 4. Okay, let's go ahead and plug in 4 and then plug in 0. And I am going to factor out that 2 in front. So I would have 4 to the 3/2 minus 0 to the 3/2. All right, 4 to the 3/2. Because the denominator is 2, that means to take the square root of 4 first, which would be 2, and then 2 cubed would be 8. And then 0 to the 3/2, well, that's just 0. And so I get an answer of 16. And I always like to write my final answer as a sentence. So I have the area of the region will be 16 and then inches squared, because my unit in this problem was inches, so area would be square inches. Let's move on to part B. Part B says, it is known that for y equals cx square root of 4 minus x squared, the derivative is given here. And this is great. They found the derivative for us. So for a particular spinning toy, the radius of the largest cross-sectional circular slice is 1.2 inches. And what is the value of c for this spinning toy? I see something about largest, about maximum, about absolute maximum. And I know that absolute extrema, so maxima and minima, occur where the derivative equals 0 or where the derivative does not exist. And that's where your maxima or minima are going to occur. In this case, our maximum. So I'm going to first find where the derivative, which they gave us, that's great, is equal to 0. And this fraction will be equal to 0 when the numerator is equal to 0. So I'm going to find this. So that's either when the value of c is 0, which I'm looking for the value of c, so I won't be using that, or where 4 minus 2x squared is equal to 0. So let's see, when I solve this, I get 2x squared equals 4, x squared equals 2, or x equals positive or negative root 2. So I'm going to check if positive root 2 is a possible answer, because if you go back and look at the graph, you can see that I'm looking at positive x values because I'm looking in the first quadrant. Now for where the derivative does not exist, that's going to be where the denominator equals 0. So squaring both sides, and then I would have, let's see, positive and negative 2 for that. All right, and so now I have the possible x values, and it says what is the value of c? So I'm going to plug in these x values into the original function. So again, I'm not going to use the c value of 0 because I'm looking for what is the value of c. And I have a positive or negative root 2 because I'm only in quadrant 1. I'm going to use an x value of positive root 2 and plug that into the original y function and see what I get. So I have y equals c times my x value, which is the square root of 2, times the square root of 4 minus x squared. Well, root 2 squared is just 2. So then I would have, let's see, root 2 times root 2 is 2. So right now I have y equals c times 2. And the y value, well, that's going to be the same thing as the radius, because in our problem they described that the spinning toy comes from that function y and it's rotated around. So therefore the radius would be the value of y, which would be 1.2. equals c times 2. So if I divide both sides by 2, I get 0.6. And you know what? I think that's going to be the answer because I can't plug in -2 because, again, I'm looking only at the first quadrant. And if I plugged in an x value of +2 into this original function, you would see that when I take the square root of 4 minus 2 squared, I would just end up with a y value of 0. So my final answer is going to be c equals 0.6, and that is for part B. If you're finding this video useful so far, make sure to give it a like and subscribe, because in the weeks building up to the AP exam, I'll be coming out with more videos as we get closer and closer. So make sure to subscribe so that you're notified of those upcoming videos to help you prepare for the AP exam. And now to our third and final part C. Part C says, for another spinning toy, the volume is 2 pi cubic inches. What is the value of C for this spinning toy? Remember, they said that this curve is going to revolve around the x-axis to give us this full toy, so we're going to use that to find the volume. So let's find the volume first, and then we'll set it equal to 2 pi after we do all the math to find the volume. So to find the volume, we are going to add up an infinite amount of disks between 0 and 2, because in part A, we calculated that 0 and 2 were these intersection points. Because we're adding up an infinite amount of disks, we're adding them up an infinite amount of circles. So our formula is going to be pi r squared, where the radius is this function right here. So it's going to be pi and then cx square root of 4 minus x squared squared. There's our pi r squared. Okay, so from here it's just a whole lot of algebra. So if I want to square what's inside, I'm going to square the c, square the x, square the radical. When I square the c, that's just a constant squared. So I'm going to bring the c squared out in front of the integral. Then I would have x squared times this radical squared would just be 4 minus x squared. Distribute in the x squared. And now integrate. Let's add 1 to the exponent and divide. Let's add 1 to the exponent and divide. And evaluate this from 0 to 2. So when I do that, I'm just going to keep the pi c squared, keeping that out in front every time. So I would have 4/3 times 2 cubed, which is 8, minus 1/5 times 2 to the 5th, which is 32, and then minus, when I plug in 0, both of these terms are going to end up being 0, so that's really nice. That would just be 0. That's going to make my math a little bit easier. I still have pi c squared, and then I would have 32/3 minus 32/5. And man, wouldn't it be great if I could just plug that in my calculator? But remember, this is a non-calculator question, so I cannot just plug those numbers into my calculator. I would have to get common denominators. I'm going to make both denominators be 15. So let's do that and that. And once you do those calculations, you would have pi c squared, and that would come out to be 64/15. So this is the volume that I calculated, and in the problem they said the volume is 2 pi cubic inches. This is where I'm going to set this equal to 2 pi and solve. Well, first I can divide both sides by pi to make that go away. And then solving for c squared, I would have c squared equals, if I multiply both sides by the reciprocal of 15/64, I would have 30/64, which can be reduced to 15/32. And then what I do is I take the square root of both sides, and normally I would do plus or minus, but in order to make this function y be in the first quadrant, I'm only going to include the c value that would be positive. So that would be the square root of 15/32, and I don't have my calculator, so I would just leave it like this, and there is my value of c. I hope you found this video helpful to help you with question number 3 on the AP free response question from 2021. If you did, make sure to subscribe so that you're notified of upcoming free response questions to help you practice for that AP exam. And make sure to give it a like and comment below about any questions that you may have about this AP problem. All right, everyone, I hope you have a great day and we'll see you in the next video. Bye.